Hello everyone. In this video, I'll discuss about the D-acronym of solid principle. Okay, so D stands for Dependency Inversion Principle, as I've written in front of you, or I've showing via my notepad. Okay. Firstly, we will go by the normal definition, and I will explain you the in briefly or in simpler terms. Okay, what actually it means. So definition, as I've written it, it states that high-level module must not depend on low-level module, but they should depend on abstraction. Now by reading this you would be thinking like what is basically this low level and high level module. Okay, now I'll explain them what are those basically, and I will explain you via example. Okay, so let's just take an example of a user class or a user service. We have it. Okay, and I'm doing some operations of saving data also. Okay, like we have a repository layer and a service layer. Okay, so like that. Okay, now so my here now my user service, or you can say the business logic, will act as a high level class. Okay, and my repository layer, that is doing the work of actually saving or some updating and all, so that will act as a low level class. Okay, so this is where I'm setting the context of high level and low level. Okay, now the definition is straightforward. Now you will be thinking like why my high level class should not depends on low level class. Basically, now my service class should depends upon repository, right? So why the definition is like that? Now I'll tell you why it should depend on abstraction and not directly on a low level. Okay, why a high level should depend on abstraction and not on low level. Okay, so let's assume in future you're saving a database, but in the future right now maybe you're saving in MongoDB. Okay, maybe you got some PostgreSDB also in build a new feature in your code base. Okay, now you have already written a repository layer. Now again you have to add another class of PostgreSDB because connection will be different, querying working will be different. Okay, saving data will be different, so those functions will be different. Okay, now you will be writing another class. So this is where your code will become complex because you have to handle that class in your service layer also. Like not everywhere you have to call the MongoDB, somewhere you have to call your PostgreSDB also. Okay, so this is how your code will become complex and also lengthy. Okay, so this is what the abstraction will solve by coming in between the high level and the low level. Okay. Now I hope this would have made you understand like why we need an abstraction between a high level and low level. Okay. Because in future we can change it, change many things. So we should be having an abstraction or abstract or interface class in between that, so that they don't directly contact, they contact via an abstraction or an interface. Okay. To make it much more clear, I'll go into the code and explain to you, okay, by going directly by the good examples and the bad examples. Okay, I have created a package of a D principle, that's a dependency inversion, and I have created two more packages of bad example and good example. Okay, first I'll go to the bad example. As I was telling about the user service and the database connection, so I have written a similar code base like that so that you understand, okay, how actually it works around. Now you can see I've created one MongoDB client class. Here I have functions of connect and then disconnect, and also have a function of execute query. Okay, so this might be some you can say repository functions. We are writing it to connect to a DB to get some data like that. Okay, and I'm not written the code of directly connecting the DB and all. I'm just writing it as out statement so that we work around with the examples. Okay, now, similarly with the Postgres DB client, I have written three functions: connect, disconnect, and execute query. Execute query. Okay, I will go to the user service. Now, this user service is where I have to call my database. Okay, now see, my code become complex the moment I have to handle two different databases. Okay, now I need to know which database it is first of all, and then what all operations I have to follow. Okay, if my client is calling this function get data from the database, okay, then he will provide me the database, which database he want to get the data, and well, like whatever ID I have to do the get call. Okay, so you can see I'm using the normal if and else. Okay, so this is what this is now my user service or my high level class is dependent on the low level class because I'm directly creating an object of low level class over here. Okay, this is how the direct relation comes into picture. This we should avoid basically. Okay, you can see I'm directly creating a new Mongo client in the user service only, and also new Postgres DB client in user service. So this is how they are becoming dependent, which we have to break it. Okay, yeah, now I'll show you the complete code, like how I'm calling it. So in the client code, you can see I've created a user service object, and that user service I'm passing a get data from service, and I'm giving here MongoDB or a Postgres DB, and whatever data I have to get, like ID for which data, for which ID I have to get the data. Okay, So this is how I'm trying to explain it out. Okay, now this is a bad example. Now let's go to the good example. Now what the first thing which I'll tell you about is I have created an interface over here. Okay, because I want to break the direct relation. Okay, so I created an interface in between them. An interface is again is having three functions: connect, disconnect, and execute query or find by ID. Okay, I have created two different functions like MongoDB. This will implement, you can see database client. See over here I've written this is implement database client, so it has to provide the functionality for all these three. Okay, among connect, disconnect, and execute query find by ID. Okay, similarly Postgres, my Postgres class is also implementing database client. Okay, it will also provide implementation for all these three functions. This is very clear enough, right? We have added an interface now, and those we have our again the repository layer. So these are like repository layers are actually implementing that interface. Okay, now I'll go to the user service. Okay, this is where the good part is. You are remembering it like in a user service of my bad example. You can see I was directly creating a new MongoDB client or new PostgreSDB client. Okay, this was making it as a direct relationship. Now in the user service, G again, G stands for good example. So wherever you see G are nothing but a good example. Okay, so you can see here I'm not doing anything else. This because now my high level class has no dependency on the low level class. I'm directly taking a data, you can say database, that is a interface parent class. Okay, that's where I'll be calling all these three functions, and whichever database client I get it, on that the function will go. If I get MongoDB, then MongoDB functions will be called. If I get PostgreSDB, PostgreSDB functions will be called. Okay, now you will be thinking like, but someone has to provide the database, right? So yeah, that will depend upon the client. So that's not my headache, it's a client's headache. Okay, whoever is calling my service, they have to provide me the database. Okay, so now you can see in the user service they are creating the objects of MongoDB or Postgres. Like now the client will tell me which DB they want to update the data or get the data. Okay, this should not be my problem, it should be problem of a client, because I need to make my code generic. Okay, yeah. So this is where now you can see first I have created a user service object. Okay, then now I've created a MongoDB. I could have also created, and like I could have written even over here database client. I don't have to write Postgres implementation G, because my interface can hold the child objects. Okay, yeah, this is fine. Even we can write post database client also. Okay, so no issues on that. I would have written Mongo implementation and Postgres implementation, but we can write even database client. Okay, that will also work. Now I'm just calling the function of get data from database by passing the objects and whatever ID. Now this ID I've written a dummy one. Okay, now if I'm passing MongoDB, my all the connect, disconnect, and find by ID will go to the MongoDB, and the moment I'm calling Postgres, it will go to the Postgres. Yeah, so what I'll do, even I'll show you by running the last code also, like the bad example code. Okay, so let it run through. Yeah, it ran. So you can see MongoDB connected, then query executed in MongoDB, disconnected from MongoDB, then Postgres, because I was calling both the functions. Okay, this is also will work same, but my code is becoming complex in the user service. I have to handle if some new, let's assume I get a new database, then again I have to write else if. Okay, so this is what my complexity and my lengthiness of a code will increase. Okay, and what I'll do, even I will run my good example so that you get a good picture of it. This will also work similarly. Okay, let's just see. Yeah, see, MongoDB connected, get data from MongoDB, MongoDB disconnected, PostgreSDB connected, get data from PostgreSDB, PostgreSDB disconnected. Okay, so I hope you guys would have understood like why we need dependency inversion. Like we want to break the direct dependency of high level classes on the low level classes by putting an interface or an abstraction in between them. Okay, so that we can scale it also, and our code should not become complex and lengthy. Okay, if you still have any questions, put it in the comments, or any other suggestions, put it in the comments. Okay, I'll definitely go and check it out. Yeah, see you in the next video. Thank you. Bye bye.